In this video, we're going to talk about, with circles, how to find arc length, so the length of an arc, like part of a circle, and sector area, so how to find the area of like a slice of pizza, kind of like this right here. So just as a bit of a SparkNotes summary here, basically to find arc length, you just find the circumference of the whole circle, and then like take whatever percentage you want for that arc. Same thing with sector area, you find the area of the whole circle, and then again just take whatever percentage of the circle that you want. So we probably should real quick refresh on how do you find the circumference of a circle. The circumference of a circle is just pi times the diameter, or sometimes you hear this called 2 pi r, because the diameter is just twice the radius. So either way, the area of a circle is pi r squared. So keep those in mind as we go throughout this lesson. So here's an example, and this symbol right here, just to be clear, this is like an O with a line through it, and it's a little sideways too, but that's a Greek letter theta. It's basically like x, it just stands for missing value, but usually we use theta when it's a missing angle. You can use x if you want, you don't have to use theta. So anyway, what is the circumference of this circle? So if I want to know all the way around the circle, you just do 2 pi times the radius, 5. Or you could do just pi times the diameter, which would be 10. Either way, you get 10 pi. So the circumference here is 10 pi. If you want to actually put that in your calculator and get out a decimal, it'd be about 31.4. All right, but now think about what's the circumference of half the circle. If the circumference of the entire circle is 10 pi, so that was all the way around, what would be just half the circle? What do you think? All we would have to do is just take this and cut it in half. So that would be 5 pi. It's as straightforward as that. So now think about, how would I find the length of an arc that makes a 72-degree angle? So if the measure of this arc is 72 degrees, how do I find the length of that arc? And it's basically like what we just did. Take the entire circumference, which was 2 pi r, it was 2 times 5 times pi, or 10 pi. And then, in this case, rather than like dividing it in half, I'm going to multiply it by whatever percentage of the circle this is. And it's actually very easy to do. Remember that the central angle matches the arc measure. So if the arc is 72 degrees, the central angle is 72 degrees. And we also know that an entire circle, either the entire central angle or the entire arc measure, is 360. So the entire thing is 360. So if I want to find what percentage of the circle this is, I'll just divide the 72 out of 360. And let's see what that is. So 72 divided by 360 is 0.2, or a fifth. So either way, you could put it as a decimal or a fraction. All I have to do is take the entire circumference and multiply it by this percentage. Either multiply it by 0.2 or multiply it by a fifth, either way. And so that would be 2 pi. And that's my answer. It's basically the same as what we did before, but before we were doing half the circle. Here we're doing a fifth of the circle. So there's a formula for this. Did I skip it? There it is. There's a formula for this. So to find arc length, which is just a portion of the circumference, here's the formula, and it's what we just did. 2 pi r is the circumference. And then you just multiply it by whatever percentage of the circle you want, which is theta, your angle measurement or your arc measure, divided by 360 because there's 360 total degrees. Another way that you might see this written sometimes, it looks like this, just kind of putting the theta out of 360 in the front, or you can put it in the back, it really doesn't matter, but just take the circumference, multiply it by that ratio there. The same thing works for sector area, just instead of using the circumference, use the area. So to find the sector area, which is the area of this sector right here, a piece of a circle, like a slice of a circle, is called a sector. So to find the area of this like piece of the pie here, once again, you just do theta out of 360 to find what percentage of it you want, and then multiply it by the full area. So for example, again, on your formula sheet it looks like this. So it's pi r squared times theta over 360. And that's because this is the area of a circle, and then you just do times whatever portion you want. So here's an example. Let's take, once again, the 72 degrees, which would mean this is also 72 degrees, and then the radius of 5. To find the sector area, you just first of all find the full area of the circle, which is pi times the radius squared, and then just multiply it by 72 out of 360. You can do these pieces separately or just kind of all together if you want. Again, 72 out of 360 was a fifth, so you could just do this and then do a fifth of it, or you can just do this all at once in your calculator. That would be 25, well, let's just make it a decimal actually. So it ends up being 5 pi, which if you want to get a decimal is 15.7 approximately. So the area of this sector here is 15.7. It's a fifth of the entire circle because 72 out of 360 is a fifth. All right, this time I want to find the sector area highlighted here. And it's got the same radius, so it's still going to be pi r squared, but this time we're going to multiply it by 160 out of 360. Whoops. This time I'm going to do this separately. What is 160 out of 360? That is 4/9. So this is 4/9 of the entire circle. Again, you could divide it all by 360 or just type all that in your calculator, honestly. 5 squared times 160 divided by 360, and then I'm going to do times pi. So it's about 34.9, and this is centimeters squared because it's area. Here's another example, and this one I want to find x, and x is actually the radius. Notice that it gave me quite a few things. First of all, it gave me this entire arc measure, which goes with the central angle, which is 310. It's almost the whole circle. And it gave me the arc length itself, which is 22 centimeters. So since they gave me the arc length, I'm going to use the arc length formula, which is that the arc length itself equals the circumference 2 pi r times the arc itself measured out of 360. 310 out of 360, what is that? That is 31 out of 36. It's not a very good fraction. So basically the only thing that's missing is the radius, which was x. So you can make that an x if you want. But basically if I want to solve for that, then just get everything away from the x until you've solved for it. Multiply both sides by 360. And then, so 360 times 22, so 7920. And then divide by 2 times 310 is 620, so I'm going to divide by 620. Or you could divide by 2 and divide by 310. And you get a decimal. It's about 12.774. Oh, I lost my x, sorry. And then lastly, divide by pi. taking the original decimal and dividing it by pi, we get about 4. So the radius is approximately 4. And if you wanted to test it out, you could do 2 pi times 4 and then do times 310 out of 360 and see if it gets you around 22. Alright, here's another angle. A circle has an inscribed angle that measures 32 degrees. So this inscribed angle is 32 degrees. And the radius of the circle is 4. So the radius is 4. Find the length of the arc intercepted by the angle. So the length of this arc here, AB. Intercepted just means the arc that it hits, basically. So for arc length, I'm going to do 2 pi times the radius, which that's the entire circumference. And then I need to multiply this by the angle of the arc out of 360. The problem is I don't know the measure of this arc quite yet. The measure of the arc matches the central angle, but that's not what I have. I have the inscribed angle. To get from the inscribed angle to the arc measure, you have to double it. So it's 64 degrees. That's also the central angle, 64 degrees. So that's what I'll put here for theta, is 64 degrees. So 2 pi times 4 times 64 over 360. And let's see what that is. So 8 times 64 divided by 360 times pi. So it's about 4.468 is the length. All right, here's another one. On this one, I want to find the area of the shaded region. So again, I'm going to find the whole area, which is pi times the radius squared, and then do times the angle out of 360. But once again, I don't actually know the angle measure. So I'm going to have to use one of the tricks we've talked about in previous videos. To solve for that angle there, there's a few ways you can do this, but one way is use the fact that if I took angle x here and subtracted this arc right here, 50, and then divide it by 2, that should give me the angle measure, 36. This was the theorem where we talked about angles outside the circle, and it was like the big arc minus the small arc divided by 2 equals the angle measure. So to solve for x, multiply by 2 on both sides, and so we get x minus 50 equals 72, and then add 50, and so x is 122. So that's the measure of this angle right here, 122, or the arc. And so that's what we're going to want to put in for this. Instead of theta, put in 122. All right, and let's see what we get. 5 squared times pi times 122 divided by 360 equals 26.6 is about the area. Again, that's centimeters squared. All right, and that is the last example.